61%. That's how many U.S. businesses experienced a software supply chain attack in 2023, according to Gartner. This attack surface is constantly expanding. To secure your software supply chain, you first need to control it. JFrog offers an end-to-end platform that manages and controls the binaries and DevOps processes across the entire software development lifecycle. With JFrog, you can deliver trusted software with speed. Visit securityweekly.com/jfrog to learn more and take control of your software supply chain today.
On the Security Weekly News, I try to scan and produce a quick look at some of the major stories to help you keep up with what's going on in and around the industry in a short format. Myself, Aaron Leyland, Josh Marpet, and other guest commentators provide greater insight every week. I'm Doug White, and I hope that you'll look for the Security Weekly News in all of your favorite podcast catchers and subscribe for the latest content.
Welcome back to Application Security Weekly. We just talked with Marissa Fagan about building security champions and finding the expectations and rewards to make those programs successful. I'm your host, Mike Shima. I'm here with John Kinsella and still here with Adrian Sanabria. Because I need some help walking through the news. It's actually been a few weeks since we've been able to go through a bunch of articles. And one in particular is CrowdStrike. Yes, we will have to join the panoply of podcasts, to be alliterative, that have covered CrowdStrike. But to warm us up a bit, I wanted to touch on kind of a low risk, not very impactful or severe vulnerability in OpenSSL, but there's a reason it spoke to me. So this was a buffer overread. The timeline in this article that I've linked to, the bug was introduced in 2011. There was actually a workaround. This behavior was identified on Android in 2014, so around 3 years later. But it wasn't fully fixed and discovered and addressed until this April in 2024. So this is well over a decade later, as a team was rewriting OpenSSL into Rust. So obviously we're fans of Rust. We're fans of this idea of rewriting or perhaps refactoring. And what's neat to me is that just that appeal that OpenSSL does seem one of those areas what probably should be rewritten into Rust. That feels like worthwhile. But it's the idea that they didn't find this behavior until people were, developers were paying attention to, well, what is this supposed to do? What is either this protocol doing? Are there logic problems or even just code and implementation problems? And all the scanners and eyeballs and, for the past decade missed this. There's one other angle tooth I'll bring in a second, but I don't want it to, I have to stop monopolizing the intro here. John, Adrian, we haven't heard from you in a while. When I bring in something like this, do you even care about like OpenSSL and an NPM protocol that's actually been dead itself for almost a decade?
Yeah, so I've run vulnerability management for much of my career, so my brain goes through a certain process, and I'm immediately looking at the exposure, the exploitability, right. Where it exists in the organization, what you can actually do with the exploit, right? I think one of the biggest travesties was the Meltdown Inspector, where we destroyed the performance of everything for almost no gain, unless you're a cloud service provider and you're worried about some cross-tenant exploitation. If you had a multi-tenant environment, you were maybe worried about it. But this kind of reminds me of this is a fun Amazon story. So there was a vulnerability. I don't know if you guys remember the Venom vulnerability in the Zen hypervisor. So this vulnerability comes out in like 2014 maybe. Not even as old as the bug that we're talking about here. And one of the things Amazon does when they fork something, when they brought Zen into the organization, is they do a code review and they pull out whatever they don't need. And one of the things they decided to pull out was the virtual floppy interface in Zen. They're like, what do we need virtual floppies for in
Floppy
EC2?
as a service in the cloud.
So they delete all that code, which in this case they're talking about this feature was abandoned. The code could have been pulled out, but it wasn't. Could have been disabled by default, but wasn't. Then when Venom comes out, every cloud service provider that is built on top of Zen, and there were a whole bunch of them, had to reboot every single customer instance. that was running on top of that. So everybody's equivalent to EC2 and anything depending on the equivalent of EC2 got rebooted. Not at AWS. They didn't have to because they had deleted that code like years prior to that. So not everybody has time to do that. That's the trick of it, is that code review, I'm sure, took a lot of time and resources, but it does kind of validate the process.
Yeah, and thank you for that story, because it does highlight the reason I pulled this in was not just because, another bug in OpenSSL, that's everybody's going to yawn at that. It's that idea, like you said, nobody needs NPN, especially right now. Why, where is the focus and time investment? Understandably, there's a trade-off, but in just removing protocols we don't use, reducing our attack surface. And you gave a really good example of how that can be, why that can be successful. I'm going to segue from there into the bigger part. So let's actually talk about CrowdStrike now. So I have a link to their PIR that they posted about what went wrong, talking about that. And I wanted to bring in, at least I'm interested in the idea this is code that's running in the kernel, especially parsing the configuration file in the kernel. Parser goes bad. There's bugs in the parsing, so the test gets missed. One of my immediate thoughts was a conversation we had with Liz a while back about eBPF. And that here in the reason I bring this up is a bit of a metaphor in behaviors. eBPF are small programs you can run in the kernel, but they get validated. And they also get tested, for example, things like, do they run to completion? So as I say that, everybody who is either pretended or actually gone through a comp sci class thinks about, the halting problem, or, et cetera, et cetera. eBPF has reduced even just what the functionality can be executed within there. So that's a way that they can get better validation. But that's where my thought goes into here. But maybe, Adrian, again, you can tell us a little bit for what you've been looking at from just what actually happened there, in case we still have a few listeners who don't know what happened with CrowdStrike.
Well, yeah, and it's important, right? It's sometimes it's good to leave these things for later, because the initial assumptions, we saw lots of bad takes out there, assumptions as to what happened, like this is why C++ needs to die, all kinds of takes like that, and once you actually, if you can be patient enough to not do the hot take 47 minutes after something happens and wait to understand how it happened, ends up being very different. So, this update, and there's many different kinds of updates that go out to antivirus products so the reason they're in the kernel early at boot in the first place, and Microsoft has special has conceded to allow antivirus vendors to run code very early in the boot process to prevent persistence of malware in the system. Because once that malware loads, it can, with that level of privileges, it can kill your antivirus, it can kill all kinds of stuff, and you lose control. So that's why it's there in the first place. But the code they put in there has to go through a review process with Microsoft. But this wasn't a code update. So you've got the actual sensor that runs in there. Then you've got updates to the sensor content, which is very broad kind of things you'd use for detecting different types of attacks at that stage of boot. And then you have rapid response content updates. This is CrowdStrike's terminology. So there was no code in this update that made everything crash. It was so one of the things they're trying to protect against are abuse of named pipes, which, as the term suggests, you're using pipes to save data to different things, to move data around, to hide data in a Windows system, and yeah. So these this thing got pushed out, and it was just some of the content that was in it wasn't well escaped or something like that, or it even though code wasn't updated. There was a bug in both the code that did the validation before it got pushed to clients. And because there was no actual software code being sent out, none of the staged release stuff applied to it. The whole point of the rapid response is that it just goes out to everybody all at once, right? And it was determined to be pretty low risk, but, now in hindsight, we know it was not low risk. And part of the solution here is they're now going to apply the same checks and stage release cycles and all that to this content, that they do to everything else already. So, you don't get to $100 billion playing fast and loose. This is a company that has its software on, as we saw, millions and millions of PCs. So it's just, I guess, a matter of time before this weird edge case hits, and they can no longer have an exemption for even content updates.
I unfortunately think I'd have to disagree with saying that a company can't get to $100 billion while playing fast and loose, and we will see the operating system which this was leveraging. But, I think would be interesting beside that. Pardon my, I pulled a John without pulling a John. I think what's interesting on this is think about from a design point of view. When you're designing the software around this, and you realize at some point in the career or the lifespan of this package, this software package, hey, sometimes we need to be able to get something out quicker. The standard release process isn't fast. Mm-hmm. Hell, that sounds pretty damn dangerous. How are we going to protect that, or how are we going to test that, or how are we going to? So I think that to me is the weakness here. Did they either not recognize that, or did they say, well, it's a pretty small chance. It's maybe like there's 1% chance of this something going wrong.
Yeah. It was a pretty small chance. I think it was that one.
Yeah.
And this is what's helpful. Thank you also, John, for bringing out that idea of the design requirements here. Because as Adrian pointed out, there is, let's call it just a race condition, or not a race condition, or a timing that's key here, is that you do need the security tool to help to come out of the secure boot, to be the first one before the malware, et cetera, undesired applications start running. So you need that precedence. And as John pointed out, you do need to be testing. You're doing this in the code, or you're doing this in the kernel. And that's why I brought in the idea of eBPF and how they approached that type of testing. OpenSSL, I did mention that. OpenSSL has gone through formal verification, where you actually do some mathy math to say, is this implemented correctly? And is the outcome going to be right? And that's a validation there, but that can be time, and it doesn't necessarily hit the same type of rapid release or rapid response that we need here. I think trying to finish, one more breath I want to throw in here, Adrian, then I'll throw it over to you, is that, Apple in 2018 said they're going to start to pull out kernel extensions, but instead we're going to give you what's called system extensions so that they can basically have a similar implementation, but live in user space. And I forgot to include these, but if you go look up Objective-C and Patrick Wardle, he has a lot of good articles from 2019, 2021, just about demonstrating how to do essentially a CrowdStrike light type of process analysis, file system analysis, et cetera. But back to you, Adrian.
Yeah, it's so the Sentinel-1 CEO, somewhat controversially came out and spoke out against how CrowdStrike had architected this and made the accusation, which isn't unfounded, that CrowdStrike was kind of abusing this privilege that Microsoft gives vendors to hook in this early. Because the intention is to go through more of a formal verification program to make sure that code they're shoving into kernel isn't going to do anything bad. And I think the argument here from CrowdStrike's side is, well, it wasn't code, right? It's content. It's different. So, it sounds like as much of a kind of a jerk move it is to come out the same week of a huge outage and say, they're playing it fast and loose. At least give it a few weeks, but. I think he might have been right on some of that in saying, hey, this was a risky approach.
And I did include an article from Microsoft that calls this out as the drivers marked as early launch anti-malware, which is just pointing out how they support this. Yeah, that's the name of the feature that you've been describing. But we only have our 30 minutes, and we can't talk about just CrowdStrike all the time because I think there's some more fun things out there. Speaking of fun things, so we were, as John mentioned this, I'll jokingly pile on. John pulled a John about talking about reaching $100 billion without perhaps being careful. I will point out that you could look at Windows operating system can probably run binaries from 20 years ago, or you can also say, Windows operating system can run binaries from 20 years ago. The way you inflect that can mean several things. But John, you also came across a bit of naming and shaming that's not from you. It's from someone else, in fact.
Yeah, this is this one really tickles me. It's low tech, but something we've covered a few times in the past. We've talked about the space of how do we make home IoT devices more secure. We've seen the European government come out with regulations of what vendors need to do, and either around vulnerability disclosures or patch management or some sort of hardening of the systems. More recently, in the last 18 months, we've seen the U.S. government start to get into this space. There's probably a few states in that space as well, but I think at that time we all came back and said, we being me, all my voices came back and said, hey, that's great, but what's going to happen? Is someone actually going to enforce this, or what's going to happen with this? So I think we've probably seen one or two legal actions on this, but this one came out last week or two. Consumer Reports. I'm not sure if they're worldwide, but in the U.S. they are. What are those? They're I think a private, nonprofit organization, but people pay them a subscription to get unbiased recommendations on, say, like an appliance you want to buy, which is the best washing machine or refrigerator or microwave or bed or lawnmower or all these type of things, which you're like, there's 10, I don't want to become an expert, who can tell me? They've got this article out called a blog post, Who Are You Going to Call? Why IoT Companies Should Embrace Vulnerability Disclosure Programs. And I'll go through the opening sentence, and it sort of sets the tone for the rest of it. Several manufacturers of common consumer connected devices, including those making locks and faucets, are not taking an essential step to ensure that their products remain secure. They surveyed 75 makers, 28% didn't have something in place, and then they go on to name those companies out. Picking through the list, Adobe, Bissell, Chamberlain, MyQ, we all have it, but it's horrible. 8 Sleep, Delta, Hydro, Level. I mean, I've got so many of the things on this list. It's really scary. Tonal, Train, Vizio, Whirlpool, Garmin, our old friends, Tuya, Ecobee. Right.
Just to clarify, that was Abode, not Adobe.
That sounded right. Nope.
Yeah. I was like, there's no way Adobe doesn't have.
It sounded wrong coming out of my mouth. This is what happens when I read quickly. Yeah. Thank you. But the rest of them, I mean, right? These are big names.
Well, and what these all have in common is they're manufacturers first, software companies second.
Yep.
So this is kind of the trend we see with IoT manufacturers that make these kind of mistakes. Is they're making products long before they start shoving software and a kernel into them.
Yeah, and Locks and Faucets is going to become my new spin-off podcast. I just love that phrase. Adrian,
sounds
as
like
you
a style of hip-hop dance.
Absolutely. Oh, yeah. And even...
You're still popping and locking? I'm locking and fauceting.
Locking and fauceting. And you point out, Adrian, manufacturers getting into security or getting into software, and security naturally must come from that. And one of the themes that I tried to pull out in this particular news segment as well is just articles that were talking about design. That's why I pulled in that OpenSSL. We talked about that CrowdStrike. Another article I had here was also a bit older one from earlier this in July from Things talking about unfashionably secure, why we use isolated VMs. And here I just thought, wow, there is a tenant isolation model that feels like it's built from the 2010s. And they stuck with it, and they've embraced it. They've explained why they like this approach for their tenant isolation. Now, to be fair, they enumerate some of the benefits they see. Importantly, they also talk about some of the drawbacks, that this is it's a lot more expensive. It's both in just you have to where you're running all of these massive amounts of VMs
margins.
And operational. You're driving your SREs probably pretty crazy. So, and as you said, Adrian, this is why you're the host of ESW. So you always helpfully bring in some good business to this. So tell us a bit more about how you react to this, just seeing this from a business or even technical perspective.
Well, in full disclosure, I worked for Things for a year and a half, so I have some inside knowledge of the company and the things they do. I'm not going to share any inside knowledge here, but they're pretty open and transparent company. That's one of the things people love about them. is they share this kind of stuff, and it's there's this kind of philosophy they have where they sweat over tiny details. And because they do that, like a lot of the delight that you have in using the product and why it's so smooth and easy to use is because they obsess over those details. But I don't think you get to do that if you get too complex with your offering, if you make certain design decisions. So knowing that they want to obsess over those details, that also kind of forces them to simplify and make decisions where it's very straightforward. To set up a customer, for example, like I had access to the tool that would create a new customer instance. It just automated all the stuff that would happen on AWS to do that. And it takes like 46 seconds or something like that, and boom, you've got a new customer ready to go in their own isolated environment with their own private keys that only they have access to. Like you can do all this cool stuff very quickly, and that. Some of that does get complex, and that's why in the back end, I think the architecture and the design of this has to be fairly simple and straightforward. And that's why you don't see them using containers for this stuff. They're still sticking to, full VMs. And if you go back a little bit in their blog posts, they've got a blog post about how they're getting frustrated with Ubuntu and not getting Ubuntu won't give them support. Because they're running on AWS, and AWS won't give them support even though they bought Ubuntu support through the marketplace. And they have this whole weird kind of issue going there. So they have to deal with those kinds of problems because they're still managing an operating system. They haven't. The trade-off is worth it to them to have these kind of headaches with Ubuntu underneath, right?
And one of the things that I also was interesting to me, they call out a false benefit of multi-cloud because you can't really just move. Here's a VM running on AWS, move it to GCP, Azure, etc. That's, as they say, false benefit. Don't need to beat the dead horse there. But one of the things here too is I can't just say my favorite thing, rewrite this in Rust and that fixes everything, because their concerns are tenant isolation, application layer vulnerabilities. It could be path traversal, authentication, authorization. Completely separate, we're talking about category error. If I just say that and thinking of a, memory safety. But if I start to say, well, what are the alternatives? And Adrian, you mentioned Kubernetes is one way of isolation. If I throw this over to John and say, well, what if they just did application layer encryption and you put a lot of IAM controls on who can decrypt what and our data encryption keys and key encryption keys? I know I like to tease and say, I love refactoring. If I start to say I love application layer encryption, does that start to become bad complexity here? Or is that just a different complexity perhaps?
The way this blog post is written, or at least the way I'm taking it and the way we've been talking about it, is like, God, they've made that so complex. They have to spin up all these separate servers and do these things, and imagine imaginations which goes on behind the scenes and the scripting. And Adrian, sorry, but that is super impressive. They can spin up a new customer in 40 seconds. My eyes went sort of wow when I heard that. When you think about the scale of what they're doing, this is the easy way to do it. Mm-hmm. So
with a unique domain name and DNS name.
Yeah. So if you want to go through and do all the application encryption or configuration or hardening or all those things that we've been talking about in this podcast for almost 300 episodes now, that's the hard way. Yeah. Because it might be easy to write, but how do you verify it? We were just talking about formal verification. Are you going to go through and fuzz all that stuff? Are you going to have the nerds come through and look at everything really closely? You go do peer reviews on it. How do you know that's done correctly? Are you rotating your keys? There's such a basket of stuff which has to be done. And then at that same time, you're hoping that there's not a problem in Kubernetes or Docker or whatever container system you're using or whatever's going on underneath it.
I like that you said basket, because that's part of the thinking behind the design here is how much stuff am I going to put in one basket? What are the failure cases where I end up taking 100% of customers down? And how can I avoid that? How can I instead encourage a model where at most I take down one or two if somebody does something stupid, does a content update on the fly?
And this is it's a very different way of thinking. Not everyone thinks this way. I spent how many years in containers? Well, not that many, but enough. That's the way if I have a software deployment which takes more than 30 minutes, I'm like, what's wrong? Are they using molasses?
You're sweating.
Right? It's that's a completely different world from where I've been the last few years. But one of the things they say in here, to beat the dead horse, stage rollouts. This approach means we can roll out code and features to subsets of customers trivially before making them generally available. CrowdStrike, are you listening? And that's right. It's a different way of thinking. It's like sometimes, you want that. It has to be out as soon as possible. But like, okay, do we really need to? Did we? Yeah. How many more customers did CrowdStrike keep safe by having that code roll out 20 minutes sooner? Mm-hmm. So that it's.
Well, and the frustrating thing with CrowdStrike is they have all that, right? Yeah. Like the customer can configure N+1, N+2. You can configure that stage rollout, but they had these content updates that were exempt from all of it. So they had it there, but weren't using it for these because, rapid response is so important. At what point is the trade-off too much?
And we've seen those types of things, that thought process that both of you are teasing out is the idea of like, well, what mistakes are we trying to avoid, or what types of mistakes or events are we most worried about that do we want to design against? And there was, I can't remember how long ago, but the joke that it's always DNS, I think it was Meta, their badge readers for their data centers had even broken down. So they couldn't, their personnel couldn't even get into a data center to address an outage because badge readers were down. And so this is the type of thing like, who thinks of that? How do you think of that? When do you think of that? And probably more importantly, I think both of you appreciate and think about more than I do. When do we invest in that? Because there's a trade-off. You're fixing the badge readers at the expense of not rolling out something else.
And this is a product that has zero impact to production for its customers.
And that's a really good point.
You're not going to get alerts from your honeypots and your honey tokens, right? Like that's the worst case scenario here, is you're just not getting early detection alerts. Yeah. And still they built it this way.
And still they did. And I'm going to take the time because we are running out of our own time. Real quick, there was an article from Cloudflare about what's the title? Avoiding downtime. Speaking of things that can go wrong, modern alternatives to outdated certificate pinning practices. And this, once again, is on the theme of just, we don't need the certificate pinning. It's a great way to do a self-DOS. And I used to be a fan of this. Go do this. But it lists out 3 excellent reasons why just having shorter certificate lifetimes are just better in general. And most of it just boils down to encouraging automation as a replacement for lots of just process, etc. Enough of that. I think that's more of the same, talking about let's revisit what we're doing these days. Is this process or this protocol still serving us? Same with NPN. And wanted to save a little bit of time at the end for John, since we haven't had you on for a while. You had no pressure because this is where we're near the end, but you had a bit deeper, more interesting type of vulnerability class that I think is not Spectre, but is in the same category of Spectre. Tell us about this ghostly type
He's going to make me try and talk about this for minutes. How do I know it? I'll be honest, guys.
In 60 seconds, tell us about timing attacks and the CPU cache.
Still not sure I fully understand this one. I found this paper last week. It's called SLUBStick. Arbitrary memory writes through practical software cross-cache attacks within the Linux kernel. Long story short, what they're doing here, this is a meaty one. I've read a decent chunk of it. I still need to go through and read the end. So if I make mistakes in here, please send a hate mail, as usual, to mike@securityweekly.com. But so what they're doing is, as Mike was saying there, it's a new way of leveraging vulnerabilities is the way I'm thinking about this. So what they do is, I'm going to sort of walk backwards into this. They took 9 different known vulnerabilities out there in the Linux kernel or a Linux platform. And they're like, how can we make these more reliable? As we've talked about in the past, if you're trying to get up on stage and actually do the song dance, go, look, it's vulnerable. That's frequently much harder than it seems with a lot of these vulnerabilities. You have sometimes only about 40% success rate, maybe lower. So the attackers, or excuse me, the researchers came up with the idea of hey, how can we make that better? So what they started looking in what's going on here is with a lot of the technologies we've had come out in modern years, recent years, with this is what happens when I'm not on the podcast for a week or two. I can't speak. I'm like this all the time. But so we have ASLR, we've got various different CPU ways of either doing memory management or memory safety or all these different things to try to minimize this footprint or this exposure to all sorts of different vulnerabilities, memory-based. And what they're doing here is they came in with the idea of like, well, we can't access and control memories easily now as we did, say, 10 years ago. What about that cache? And Mike mentioned Spectre, so, okay, well, don't we have cache protection by now? We should be able to have that. What they figured out here is a form of a timing attack. So basically what happens in a Linux kernel is you're going through from process to process, is you load up your cache as instructions are called, or if you're doing prefetch or different ways of doing it. You get data in your cache, general cache. Application uses that as it's going through its time slices. At some point, those get flushed out. The next process comes in, starts doing its thing, or maybe you go switch the section of memory you're using, section of cache you're using for the next process. In this case, what they figured out is a timing attack in there that as the kernel is trying to swap from, as the kernel is moving from one of those slices to the next, one process to the next, hey, can I grab on there for a second and can I manipulate that cache? Okay. So the kernel now goes, hey, that data has been manipulated, it's dirty, can't use that cache, so that cache is invalidated. Let's go and actually allocate a new cache section. You do this enough times, what ends up happening is you are now decreasing the available footprint for where that cache is going to be allocated for the next process when it comes back. So now you know more accurately where that's going to come from. You're able to put commands in there or do things with that. So this is the first of 3 steps which they had to be able to, that they're using in this paper. The overall result is that 40% number which I was talking about. They're now up to 90% accuracy, 90% success rate with being able to leverage 9 vulnerabilities which we've seen from the past. So this is sort of it's a new thing, right? So usually when we see something like this, we're going to see more papers come out over the next few months or few years of like, hey, we've got this cool thing. How can we use it more efficiently, more accurately? There are no ways of protecting against this currently, either at a hardware or a software level. They've sent this out to the Linux kernel security folks. As Adrian was saying earlier, we don't want to just slow down the kernel for not a lot of security improvements, so we'll see what they do with this. But yeah, I don't know. I'm yapping if you guys have had a chance to sort of scan through that or any thoughts or comments about where we go from here.
Well, I mean, they're talking about reducing crashing in the kernel from 40% to 99%. Seems like maybe CrowdStrike could use that to do content updates. I had to. I'm sorry. I had to.
We'll celebrate that. And I think the only thing I can add there is similar, just the joking response that basically, you know, if you have shell access on a Linux, you basically, any shell access is root access, is kind of what this is sort of teasing out, which I will say leads to that design choices of VMs, using VMs for tenant isolation, or where are the boundaries of isolation that you want to enforce here. And so really, I think that's the best I could do.
Really briefly for our listeners, it actually took me a while to find the PDF on this one. So it's in our show notes. At least as of today, when I go Googling around for it, I get like some high level articles and some of our friends' other security news sites out there. But like if you want the PDF, we've got it in our show notes, and it's a meaty one.
It is a meaty one. And this has been a meaty, strange metaphor for a podcast segment of the news, but it was meaty. Thank you, John. Thank you, Adrian. This was a fun conversation. Once again, yes, indeed. Thank you, everyone, for joining us. Please do remember to send those emails in, as John instructed. And while you're sending those emails, please subscribe, share on the socials, check out the show notes, because you can find all kinds of fun links and more articles in there. And speaking of a song and dance, check out City of Dreams by Aisle 9. We'll see you next time on Application Security Weekly.